Explain what is meant by an 80% confidence interval. Right, an 80% confidence interval means that there is a probability of 0.8 that the population mean will be included in the interval. A group of students were given an algebra test which consists of 50 questions. Afterwards they were given a 2-week course of algebra, at the end of which they were given another test of 50 questions. The results of the sample of the 7 students were given below. So we've got 7 students here. These were their pre-test scores and these were their post-test scores. First of all, calculate the sample mean and an unbiased estimate for the population variance of the difference of means. Now let's have a look what we mean by why we're going to do the difference of means. As 2 sets of data are not independent, they're not independent because it's the same student each time, we will need to find the confidence interval, that's what we're going to do eventually, by pairing the data. Okay, because the data is not independent. This is actually the same student. This is a different student, but these scores belong to that student. So, using the GDC, what we're going to do is input this information into the GDC. So you need to do this carefully. We need to go to spreadsheet and put in the data very carefully. So I'm going to put in 24, enter, 36, enter, 31, enter, 37, enter, 43, enter, 19, enter, and 7, enter. Notice we've got 7 students here. So scroll back to the second column and go back to the top. We're going to put in 26, enter, 34, enter, 35, enter, 38, enter, 46, enter, 23, enter, and 5, enter. Now, because we want to look at the difference in column C, we're going to put in the difference, but we can get the calculator to show me the difference. Now, the difference was going to be equal to, we're looking for an improvement, so it's going to be B1, column B, take away column A, enter. Right, if we put it back on there, and if we want to do right click, so it's control menu on your calculator, so you get right click, I can just do right click, do copy, and then scroll down to all these. Just make sure we don't go down too far, it's a little bit fiddly. Maybe we can do it that way. Oh, okay, it's a little bit fiddly, so we'll just want a little bit fiddly on the calculator because it goes a bit too far. Okay, and then do right click again, so control menu and then paste. It will paste all the differences in there for us. Okay, put your cursor on there and we'll come back to that in a minute. There's a screenshot of what I've done. Okay, so we're going to put that into some sort of table on our exam sheet or our working out. So here's the pre-test scores in the column, better the working columns, post-test score, and these are the differences. We have to calculate the mean and the unbiased estimate of the variance. So to do that, we'll go back to our calculator. Okay, and we're just going to calculate it on the difference. So if you put the cursor there to begin with on C1, so do menu, statistics, stat calculations, 1 variable statistics, number of lists. It's only going to be 1 because we only wanted to consider C now, the difference. We're not worried about A and B. Press OK, and we want to consider C. Each of those occurs once, and it will put it in the next available column, which is D. That's what happens when you put the cursor on the last available column. Press OK, and we will get the mean here being 1.43, and the unbiased estimate of the standard deviation will be here. So that's the screenshots of what we just done. Okay, we should put some working out. So x bar is sigma x over n. So we can get that sigma x, and we know there was 7 in the sample. So put in the information 10 over 7, which gives me 1.43, correct to 3 significant figures. And then the unbiased estimate of the standard deviation will be n over n minus 1, sigma x squared divided by n minus x bar squared. So we've got sigma x squared here, which is 54. So it would be 7 over 6, 54 over 6, sorry, 54 over 7. 54 over 7 minus 1.428 all squared. That will give me 2.57275, which rounded off to 2.57. That's for the unbiased estimate of the standard deviation, but we want the variance, it says in the question, so you have to square that. So the variance will be 2.57 and a bit more squared, which will give me 6.62. However, this is more useful in the next part of the question. Right, find an 80% confidence interval for the difference of means, stating any assumptions you made. Well, the assumption we made is that the data is not independent. We've already discussed that. So, for an 80% confidence interval, x bar is plus or minus t Sn of minus 1 over root n. Now we're going to, if we draw a diagram, we want the central part to be 0.8 or 80%. This will be 10%. The important thing is the degrees of freedom will be 6, 7 minus 1. So that's going to be 1.42 plus or minus. Now I've got this number here, 1.440. This value can be calculated from the GDC, and afterwards I will show you how to do that, times the unbiased estimate of the standard deviation divided by the square root of the sample size, which is 7. These can be worked out using the GDC. So going to the GDC, right, now calculating a confidence interval. So we're going to go to menu, statistics, confidence interval, and we want a t interval. We're going to use the data, and it will select the data from C, and we'll probably want it to put it in a different column. So I'm going to put column F, but the confidence interval was 80%, we want 0.8, and press OK, and then we'll get our interval values here, 0.0285 and 2.83 from the calculator, these two values here. So here are screenshots of that. And therefore we get the two values here, 0.0285, 2.83. Now, that's the answer. This bit's not really essential to actually put in the exam, but if you want to know how to calculate this value, so it's going to be, if we go to another screen, so draw the graph again. Okay, we want an area of 90%, so using the GDC, and the degrees of freedom is 6. So going to my GDC, I'm going to the home key and select a calculation mode, and now go menu, probability, distributions, and want inverse t, and the area was 0.9. and the degrees of freedom was 6. Press OK, and then you can see here we get an answer of 1.439. If we round that off, we get 97. If we round that off, we're going to get 1.440. So t will be equal to 1.440. Although this part is not essential in an exam question.